everybody, my name is Federico Olivieri. I'm a network automation engineer at Ticketmaster, and today I'm going to talk about network as a code. This is the agenda. I'm going to cover briefly the tools that we use to develop this network as a code, and I'm going to compare how we were working before and how we are working now. And I would like to spend some time on the demo just to show you real case study and how this system works. So hopefully you can get some ideas from it. These are the tools that we have been using in the past years. We are a company that we believe in open source. So whatever we use is open source based, and we also, when we had a chance, decided to contribute back to the community with things that maybe we developed along the way. A brief introduction about Ticketmaster. Ticketmaster is a company with hundreds of devices across all the world in different Live Nation venues, plus different DCs. And at some point, Ticketmaster decided to go with the PCI compliance, and PCI compliance required a lot of work for configuration hardening and a lot of checks and control to make sure that those pieces of configuration that was always there at any point in time. So we look at the DevOps guys, we look at the concept of infrastructure as a code, and basically we apply the same principle to the network. And that's why we came with the network as a code as a product. So this is how we worked before. Different vendors, different OS version, different hardware meant different blueprints in Excel file where we copy, we put a notepad, we change the moving bits like IP addresses, source name, and things like that. Copy and paste in the shell when we need to provision a new device, or even when we need to change bits of configuration. And we found ourselves most of the time troubleshoot the typos. As you can see in this workflow, the interaction is between the network engineer and the network device. This is important because now you see how it's going to change. So that's how we are working now. Basically, we abstract all the blueprint and we move all the moving bits in a YAML file. The YAML file is very readable and easy structure, so even I'm not technical person can easily understand what a YAML file means. Then we have Git that we source control all the changes through our network, and we have a CI/CD pipeline that's going to take care of pushing the changes, do the test, and give us back the result that we can check if it's what we wanted. As you can see here, the interaction in this system is not between the user and between the network engineer and the network, but it's between the user. So a user can even be a network engineer, and the pipeline, and then the pipeline is interacting with the network equipment and is feeding back to the user the result. This is our workflow. So we wanted to enforce a kind of workflow to make sure that we didn't break anything, because obviously pushing changes through hundreds of devices means if you do something wrong, you're going to break those hundreds of devices. So this is our workflow. We update the variables in a YAML file. We push the changes in a dev branch, and we see the result. We will see what is behind this YAML file that is going to anticipate. It's a Jinja template that is going to render config. If dev is okay, we do a kind of syntax check just to enforce some styling, make sure everyone is working in the same way. Then we provision Ansible Tower. Ansible Tower is the UI interface because we want to have like a central point that every teams could log in and check the result. And we run the playbook in dev. If it's okay, we can now merge in staging. In staging, we have a physical hardware that covers pretty much all the hardware we have across the network. And we run different steps in staging where we get facts, we do some pre-checks, we do the configuration, we do some post-checks, and we make sure the configuration is idempotent. If something goes wrong, we can also trigger a rollback. If all the stages are okay and staging is a green thumbs up, okay, we can merge in master. We can review within our team, so we can do some code review before to go in production. To be honest, this code review is happening even before when it's going in dev in stage. So, like I say, we use Git. Git, we found very many benefits compared to what we used before. So in Git, more people can contribute. So you don't have the concept of share Excel file, but of the contribute. We can keep track of every commit with a specific SHA. That's something was very difficult to keep track in Excel. So you can know, you can see who is doing what. We have a very useful diff to every change you push in Git, in this case Gitlab, where you can see what you had before and what you have now. And you can enforce kind of workflow. So when you have in dev, you need for kind of person to approve. Staging, same master, you might want to have kind of manager approval as well, so you can enforce some kind of workflow. And that's an example when basically someone's pushing a change in staging. I'm not happy with that. I'm gonna just leave a comment and point my finger against a specific line or a specific file. Git, in a specific case, GitLab has a integration with the GitLab runner, but GitHub, Bitbucket, all of them they have integration with the CI/CD, so you can easily integrate your Git with the engine of the runner, and that's a way to enforce workflow as well. Because if a pipeline is not okay, you cannot move to the next step, so you cannot merge in from dev to master. And you will see now in GitLab that's very easy to use this CI/CD. Like I was saying, we have a GitLab runner that is the engine. It's very easy to configure because it's provisioned by a YAML file. So with a YAML file called gitlab-ci.yaml, you can basically instruct the pipeline and telling what to do. You have a runner that is the engine. Like I was saying, it's very easy to deploy. It can be a container, it can be a virtual machine, it can be whatever you like. You can see all the steps of the pipeline in the example above. And like I was saying before, you must make sure that the pipeline is successful before to move forward. Otherwise, you cannot merge into from dev to staging, from staging to master. Going back to the Excel stuff, so I say that we put our variable in a YAML file, and behind the scenes, those YAML variables are going to feed a template, in this case a Jinja 2 template. Jinja 2 is very powerful because it allows to create one template for all the specific cases. We used to say one template to rule them all. Here we have a few examples where, for example, in Cisco US, based on the version, you can render template with different logging line. Okay, in the first case you have logging and then the IP. In the other case you have logging host and then the IP. Okay, is vendor agnostic, so based on the vendor, so based on the get facts that you retrieve from the device, you can render a Cisco syntax template or Juniper, for example, here for the NTP on the right-hand side. It's model agnostic, so that's one of the biggest challenge we had. As you know, Cisco devices, they have different platform, different hardware, which means sometimes different syntax or different commands. So you can still use, you can do clever stuff. So based on the model version, you render some line or other lines. And you can see on the bottom of the right corner a YAML structure for variables for NTP server. It's very easy to understand. You don't need to be like a Python savior, so whatever you can understand that this is a kind of NTP server is a list of NTP servers and structure of dictionary. Zero touch CLI. So we wanted, since we were there working the PCI, we wanted also to have a kind of way to plug in a new device with a basic management configuration and push the config that we need. And so we start to have a look around what we had, and we realized that we had some devices that supported the config replace. So where we push all the config, a full config, and the device is keeping care of do a diff between the running config candidate and apply the diff. As you can see on the top right, and we'll see a demo shortly. While in other kind of devices like Cisco, you do not have this kind of functionality, like a native functionality by OS, but we could have a kind of diff approach, we used to call it, where we can basically find the bits that we want to check in the config and make sure that those bits are exactly what we have in our repository, in our variable. If not, we are going to do a kind of remove and add work. Like I was saying, I went through all these things very quickly because I want to show you our demo. So here we have a case where we have an NTP server, and the same NTP server is defined in my variable, as you can see here. Now I'm gonna add a fake NTP server. I'm gonna do manually. Okay. And here you can see that the fake NTP server are in the running config. So we have 3 NTP server. In my variables, I'm gonna enable a legal NTP server. So now I want 2 NTP server. I want the 32.5 and the 33.5. But remember, I still have 1 legal and 2 fake IP server. So what I'm gonna do, I'm gonna update my variables. I'm gonna push the changes. And this is a GitLab CI file I was telling you. I defined 2 bits, that is like the dev branch where I'm working, and the tag. The tag is like to narrow down the area where I'm working at. And I push my changes in the dev. So here you can see the staging, the stages for AWS provisioning, the syntax check, and now we are opening this. We will see the API interaction between the GitLab runner and Ansible Tower. That the runner is gonna drive AWS, and AWS is gonna run a specific job for NTP only because we use a tag NTP. What it's gonna do is gonna look at the running config and compare the NTP addresses we have in the running config with what I have in my variables. Okay, so we have pre-config changes, get facts. That's an example where someone, for example, insert a bogus IP, okay, and that those IP are not validated in my repo. As you can see here in the orange, the playbook realized that there are 2 IP servers that we don't have in the variable, so they are removed, as well as it realized there is an extra IP server that I want to push, so it's gonna configure the NTP server as well. Obviously, because we have access lists, we have a kind of, the playbook kind of intelligence is going to update the NTP as well, and it's going to remove the access list line for the fake NTP addresses. And now it's going to do some post checks. So as you can see here, it's failing because the post check is to make sure the new NTP are up in sync. Okay, this is the raw debug, and the new NTP server is not synchronized. Okay, so this is the post config check. This is my test. I want to make sure the NTP is up and running. This is happened because it's going to take some time. But as you can see, it's going to take some time for NTP to synchronize. But as you can see now, let's pretend we haven't seen the error, and we want to merge from dev into staging. We create a merge request. As you can see here, we have a red pipeline result. Compare branches and continue, and we submit the merge request. And as you can see here, we cannot merge in staging as long as the pipeline is not okay. So what we're gonna do, we are gonna rerun because we are quite confident in the meantime the NTP synchronized properly. While it's executing, we are gonna show the config for the NTP. We're gonna see the device that the bogus servers are removed and the new one is being added. We can also see that now it's synchronized, so we expect to see a green result. So we run again the job. This time no config change will be applied because the playbook is smart enough to understand that what we have in the running is exactly what we have in the variables. So on the left-hand side, you see the pipeline std out, while on the right-hand side, you see the AWX std out. As you can see here now, the NTP in sync, and we are okay. We want to make sure to run the tests every time, even if you don't apply the changes, because we want to make sure that everything is looking okay. So from here, we can see that whatever is in the repository is exactly what we have in the running config. Whatever is in the running config but is not in the repository is going to be deleted. So that's a way to enforce source control. That's the PCI guys were quite happy with that because running this as a cron job daily, you can make sure that what you have, what you want as a configuration is exactly what you will have in the end. Everything is fine, everything is green, and now we can merge in staging. Like I was telling you before, staging we have different steps when we want to be more accurate. We have get facts, we have pre-change checks, config change, post-change checks, and we have idempotency. We realized that thanks to the power of the workflow template in AWX. Workflow define different steps in AWX where you put together like very cool UI interface where you just drag and drop the blocks, and every block is basically one of the job. And the workflow is going through all these blocks, as you can see here. On the left-hand side, we run the workflow for the staging. And here we have the pre-config change. And in this case, when we work in staging, we want to run the playbook for all the management config. In this case, is NTP VTY as well, because in the dev it makes sense to test your changes only, but in staging you want to make sure that all the configuration, so what you're going to push is going to look exactly as you want. As you can see, the pre-change checks are okay. Now we're going to run the config change. So we're going to get some facts. We're going to do some pre-change as well. Working with this workflow, we realized the past months that we could even improve this way to work. But this is tended to be a very good, I can say, blueprint for workflow where we could break down the pipeline different steps. But we then later realized that we could even do more improvements. In this case, as you can see here, there are no changes to be applied for VTY and TP. In real case, we have DNS, we have TACACS, we have SMP, so all the management things are enforced by this. And the config change stage is okay. Now we run the post change checks, so we retrieve all the test result to make sure that everything is okay. For the VTY, we have some kind of show commands, and we're going to look for the user login. If I'm not mistaken, for NTP, like I was saying, we're going to look for the synchronize server. And we have some failed task that in this case I skipped because everything is looking okay. And now we're gonna run the idempotency task. So we make sure that the config is idempotent, which means if the configuration I want is already there, I'm not gonna push my config again. And after that, we are basically ready to merge in master. The idempotency works with basically a list where we put for every step we put the result, and if one of these results is true, it means that a change has been applied, and if a change has been applied, it means the playbook is not idempotent. So I want it to fail. I have to go back and look at my work and make it idempotent. Everything is good, so we are good to move in production now. I'm not gonna bother you through the production stuff, but I mean, just to give you an idea how it works. So from now on, when we push in production, all the changes, the changes will be pushed across all the network. So we could see the idempotency was okay. We've got green result on the pipeline on the left-hand side. Job succeed, and we are okay to merge in master. This is an extra demo, very quickly. That's quite cool, actually, because we started to deploy a new kind of network spinal leaf. So with Arista, so we wanted a very quick and easy way to plug in a switch and deploy the new configuration. We defined some variables for the BGP for interfaces. This is a vagrant environment, so virtual IOS base. We use Napalm to do config replace. I'm going here showing you the variables that we are going to push per device. This is the template. Obviously, the demo is very basic template. This template is going to take all the variables I showed you before. It's going to render the config. So this is a spine device where we do show running config. This, as you can see here, just a full config, and we can see BGP neighbor up. Okay. We log in the other device, and we can see even here we have the host name, we have config, and we have the BGP app. But both switches, they are missing one neighbor, that is the leaf 2. The leaf 2 has a basic management configuration. As you can see here, it doesn't have host name, it doesn't have anything. You just plug in this case it's a vagrant, so a virtual connection, but ideally this would be a physical device where has a management and connection, no BGP whatsoever. So what we're going to do, we're going to run our playbook, and we're going to apply our config replace. This is run locally on my laptop, but this works well in AWS as well. So we're going to render the config. We're going to do a diff between the running config and the candidate, and that's it. Config is applied. It's very basic. There are no tests. There is anything else. But now we have new device that has a new config in a few seconds, and we are directly root got from BGP. As you can see here, these are the interfaces defined for my switch. This is the loopback of leaf 1. We can ping it. Yeah, that's pretty much it. I was being my network engineer myself. I going through network automation. The first time was a bit challenging. I thought it could be a good idea to share some of my experience. Nothing really serious, I have to say, but yeah, most of the time I realized that I wanted the perfect tool, the perfect application. So I started to bring out a lot of feature, and I ended up to not complete anything, not having anything working. So I start to reduce my expectations. So I start to build small piece after small piece. I also soon realized that from great power comes great responsibility. Like I was saying, in a click, you can deploy configuration, but you can also destroy a network if your configuration is not okay. Uh, Also realized that I was the only one talking about network automation team, so I realized that I needed to be more explicit and simple as possible the code. So even the super skilled guys, they could work with the application. Okay, uh, it's gonna take some time learn automation, especially if you come up from like a classic network background. Remember to share what you are doing because all the tools show so far have been developed by someone else that they kindly share with the community, so I could take them and use it. Once if I have chance, if I build something that I think it can be useful, I just push it back to the community, send it back to the community, and say, "Look, that's what I've done. You can use it." Obviously, before to start automation, it's good to have kind of a clean environment, or at least as much as clean as possible. You can reach me out on GitHub, where is my code, on Medium, where I post blogs, where I post some articles, LinkedIn, Twitter. And now it's time for Q&A. Thanks for watching, and I hope you found it interesting.